Good morning to all. Today we are going to learn type 5 integration, that is known as integration by parts. What is mean integration by parts? Till now we have come across there are 4 exercises. In these 4 exercises we have 4 type of integrals. We have list of formulas also. Learn again. Now the type 5 includes integration by parts. That is very easy. This type of integrals is used when two functions they are in product. That is integral x sin x, integral x sin x into dx. If it is integral sin x, we have formula, or integral x dx, we have formula. For integral x into sin x, we don't have formula to integrate directly. So these type of problems, the integrand as a product of two functions, we can apply integration by parts. Before entering into this, just look at the product formula of differentiation. What is the differentiation of ub? d by dx of uv equal to derivative of uv. The two functions are in product. What is the derivative? Which is equal to u into v dash plus u dash into v. We have learned already. U into v dash plus u dash into v, or we can write it as u into dv by dx plus v into du by dx. V into du by dx. Keep one function as constant, differentiate the other function. Then differentiate the first function, then keep the second function as constant. That is the derivative of the uv, product rule of differentiation. Now here integrate on both sides. Integral d by dx of uv into dx equal to integral u dv by dx into dx plus integrating here, I am writing again, d by dx of uv equal to u into dv by dx plus v into du by dx is the differential formula. Now integrate this value. Integral d by dx of uv into dx, integral u into dv by dx into dx plus integral v into du by dx into dx. I am integrating the derivative function, which implies now dx and dx get cancelled. Here dx cancel, here dx get cancelled. The remaining are integral d of uv equal to integral u into dv plus integral v into du. U into dv plus v into du. d of uv. Now integral dx means x. Integral dx is equal to x. Integral d of uv equal to uv. Integral dx is d of x, that is dx is x means d of uv implies uv. Now which implies uv equal to integral u dv plus integral v du. Now we are concluding on formula from this. Bring this integral v du left side. uv minus integral v du equal to integral u dv. So this is the formula for integration by parts. We are going to apply in integration by parts. that is known as integral u dv equal to uv minus integral v du. This formula is known as integration by parts formula. Integral u dv equal to uv minus integral v du. Here the given function, in the given function, for example x sin x is given, sin x dx is given. Take one function as u and another one as dv, the remaining as dv, which is equal to integral u dv. So one function is taken as u and the remaining are taken as dv. From this dv you will find v, then apply in the formula. So the given integral as a product of two functions, take one function as u and then take the remaining terms as dv. From this dv find v value and then substitute in the formula, you will easily get the answer. To choose u, we have some of the ideas. I'll clear now. So this is the formula in the integration by parts method we are using. So add this formula in the list, integral u dv equal to uv minus integral v du. Add one more formula. This is the formula, and another formula, Bernoulli formula. These two only applied in the exercise number 2.5 fully. So this is very important. Integral u dv equal to uv minus integral v du. When it is applicable, when the given integral, given function, the integral function, given function is in product of two functions, we can use this method. Take one function as u, the remaining terms in the remaining function with the dx is taken as dv, and then from the dv we will find v, and then uv substitute in this and then integrate, we will get the answer. Now we are moving some of the formulas here. Now I have written all the 6 questions in the exercise 2.5. One is x e power minus x, another one is x cube e power 3x, then next one is log x, then another one is x log x, the fifth one is x power n log s, the sixth one is x power 5 e power x square. It's okay. These typical problems, which one is taken as u? There are two functions are in product. Here only one function, left it. There are 5 functions here. Each contains 5 problems, each contains product of 2 functions. So these type of cases we can apply integration by parts. So which one is chosen as u? Which one is taken as dv? That is the problem here. If you chosen wrongly, the problem will not complete. It will goes and goes. It will not end at a point. So the point that value of u is chosen is very must. To choose u, we have some ideas that is known as isolate. Use the method of isolate. This is some idea to choose the function as u, another function as dv, remaining as integral dv function. So these are all in the form of integral u dv. This is u dv, this is also u dv, this is also u dv, this is also dv, this one is also in the form of u dv. Okay, now but here we have only one function, but here also we have 2 different functions on product. Now here use the rule isolate. You can choose the respective function as u, which function is taken as u, and which another function is taken as dv. So use the rule for isolate. Isolate means this is inverse trigonometric function. As if the inverse trigonometric function appears in the given problem, first take it as u, inverse trigonometric functions. If inverse trigonometric appears in the problem, first give priority to choose u as that inverse function, inverse trigonometric function. I means inverse trigonometry. This is the first priority given to choose u. To choose u, we are to choose u, we have these type of ideas. So the inverse trigonometric function appears in the given problem. First of all, take it as u. Else, or logarithmic problem appears. If inverse is not appeared in the given problem, logarithmic function appears. L means logarithmic function. If logarithmic function appears, you can give next priority to choose u as logarithmic function. Suppose these two are not entered in the problem, but the third priority is given to algebraic functions. What are the algebraic functions? X power n, x to the power n, x cube, x power 4, x power 5, like that. The algebraic functions appears, give the next priority. If it contains inverse, choose u as inverse trigonometric. If it is not contains, check whether logarithmic function appears, take logarithmic function as u. If both are not entered in the question, not appeared in the question, so check any algebraic functions appears in the question, that is take that algebraic function as u. So the three were not present, then go to trigonometric function. Here inverse trigonometric, here trigonometric functions, T for trigonometric functions. If any of the trigonometric functions, not inverse trigonometric, any trigonometric function, sin x, cos x, sin inverse cos x are inverse trigonometric, sin, cos, tan, like that, they are trigonometric functions appears. You can give next priority to trigonometric functions, and then these four not appear, the exponential function appears. Fifth one is exponential function. Exponential function appears. A power x, e power x, like that, e power 5x, e power 3x, these are all exponential functions. E power minus x, e power 2x, e power x square, these are all exponential functions. Then last priority given to exponential functions. If you take in this order, you can easily complete the problem. For that purpose only they have segregated this idea. So I means inverse in trigonometry function. If inverse trigonometry function appears, choose u as inverse trigonometry. If the first one is not appeared, look at the question. If logarithmic functions appears, choose it as u. Suppose both not appeared, then if any algebraic functions, they are x, x power n, x power 5, x cube, x, these are all algebraic functions, take that one as u. Suppose if these three are not appeared, the only trigonometric functions appears, means you can choose, for example, integral x square e power x. In this case, choose trigonometry function as u and then e power x as dv. Okay. Then if suppose x square is not a trigonometry function, right, next one, trigonometric functions. Trigonometric functions means any of the trigonometry for sin x, cos x, like that. For sin x, e power x. Sin x, e power x appears, integral e power x sin x dx. In this problem, choose sin x as u and then take remaining as dv. That is udv format. Now, and then last priority given to exponential function. So just to keep in mind, when we choose a integration by parts method, give prioritize according to this way, you will complete the problem easily. So first of all, I means inverse appears first priority. If inverse not appeared, go to logarithmic function. If logarithmic function also is not appeared, go to algebraic function. If algebraic is not appeared, go to trigonometry, and trigonometry is also not appear, and then check if exponential, if this is the order given to isolate. Bernoulli formula. This is familiar in the name of Bernoulli's. This is also used when the functions are in product. In this Bernoulli formula, and the Bernoulli formula is applicable only if the function u is in the form of x power n. U is an algebraic function, that is in the form of x power n, and the power n is a positive integer. In this particular case only this Bernoulli formula is used. For other cases you should not use. Here look at the first problem, x power n, and then here we can use a Bernoulli formula. Here power n is 1, and also e power x is the second term. Isolate, in the mean of isolate, e is at the last, so given priority to u to equal to x. So u equal to x, here power is 1, so you can use this Bernoulli type of formula. And then for the second sum also, a algebraic function, exponential function. So algebraic function is taken as u. In that case the power is positive, so you can choose Bernoulli formula. Here we can go with Bernoulli, and second sum also we can go with Bernoulli formula. And the third case we cannot apply because here no x term, so it is not possible for question number 3. The question number 4, x log x, by the order of priority L logarithmic in the second priority given to logarithmic. So the next priority is for algebraic functions. Here we cannot apply because u is taken as log x here. For log x functions, u as a log x function, we cannot apply Bernoulli formula. So these two cases omitted. And the fifth one, look at here. Here also we have log x as a function. So then we can move to algebraic functions. Here we cannot apply. And in the sixth question, here exponential, here algebraic. So order of priority, algebraic is given first. So here we can use a Bernoulli formula. So the three of sums problems, question number 1, 2 and 6, we can use Bernoulli's formula, and the remaining 3 we can go to the direct formula of integration by parts, integral u dv equal to uv minus integral v du. Okay, what is that Bernoulli formula? The Bernoulli formula is taken as the given function is in the form of u dv, and then it will be equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc., which implies u dash, u double dash, u triple dash, etc. are successive derivatives of u, consecutively differentiate u once u dash. This is the second derivative of u, this is the third derivative of u. How many times required you can differentiate till the value of derivative of u becomes 0, you can differentiate. And then here v1, v2, v3 etc. represents then their successive integral values, repeated integral of x or successive integral, repeated integral values of v, that is very important. v1, v2, v3 are repeated integration. U dash, u double dash, u triple dash are successive differentiation. So after finding these, you can substitute in the formula integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. This formula is known as Bernoulli formula. It is only applicable when u equal to x power n, the power of n is a positive integer. For other cases it will not be applied. I think it is clear to you. For Bernoulli formula, u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 etc. till the derivative of u tend to 0, you can differentiate, then stop the process. According to it, you can integrate the value of v, then multiply the values, then plus minus alternately give the sign, simplify the problem, you will get the answer. That is known as Bernoulli formula. Method of Bernoulli's formula you can do like this way. And then for the first case, integration by parts, integral u dv equal to uv minus integral v du. We have another formula, u dv equal to uv minus integral v du. First of all, you can choose the formula according to the problem, then you can get into the problem. Question number 1, x e power minus x, exercise 5.2. Exercise number 5.2. Question number 1. X e power minus x is given. There are two functions, they are in product. We want to integrate this function x e power minus x. So integrand as a product of two functions, we can go with the integration by parts. So integral x e power minus x dx, it will be equal to integral u dv. It is taken as integral u dv. The whole function with dx is taken as u dv. Here there are two functions, one is algebraic, another one is exponential. By the use of highlight, inverse, logarithmic, algebraic, trigonometric, exponential. Inverse, logarithmic, algebraic, trigonometric, exponential, which is given priority to take as u. To choose u, the priority given to here algebraic and exponential. Algebraic is the given more priority, so that is u. To choose u, we are following this method. So u equal to algebraic. Algebraic means x power 1. Here x is the algebraic function. So e power minus x is exponential. So I have chosen u as x. So the remaining term are all taken as dv, and dv equal to the remaining are e power minus x dx. E power minus x dx are all dv. Can we go with the Bernoulli formula here? Yes, we can go with the Bernoulli, because in the Bernoulli form u must be the algebraic function. Its power is a positive term. So this is 1 we have the power. So it's a positive term. It is an algebraic function. We can go with the Bernoulli formula. Right. In the Bernoulli we have formula integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. is the formula. Right here Bernoulli's formula. Okay. How long we can go this? When the derivative of u becomes 0, we can go. Right. So u dash equal to, u dash is derivative of x with respect to x is 1. U double dash is equal to, what is the derivative of 1 with respect to x? 0. Then integrate here. Integral dv equal to, apply integral symbol, both sides e power minus x dx. Now we are using the previous formulas that I have learned in the first 4 exercises. Now integral dv equal to v e power minus x, integral e power minus x dx equal to minus e power minus x plus c. When we simplify, we will get a minus e power minus x. Otherwise, e power minus x divided by minus 1 plus c. Then the next step, it will be minus e power minus x. So you need not add c here, because we are going to integrate repeatedly. So just integrate the one minus e power minus x. Now u double dash becomes 0. Now this one is v only we have found. When integrating dv, we can find v. So we should go 2 more steps here. v1 equal to integral of e power minus x, again minus e power minus, so minus of this integral value is minus e power minus x. Totally we have e power minus x, and v2. You need not find v2 because u double dash becomes 0. When we product u double dash and v2 are multiplied, so these two become 0 anyway, but we can find v2. So e power minus x means again minus e power minus x. These are all integrals. Look very carefully here. These are all integral values. I am integrating here, but here I am differentiating. These are all derivatives, u dash, u double dash. When we apply the powers u dash, u double dash, they are all derivatives, differentials, successive differentials. Here they are all integral. First find v. This is not v1. From integral dv we can find v first. Then we can go to 2 more integrals, that is v1 and v2. Now substituting these values in the formula, we will get the answer easily. That is integral, right here, integral x e power minus x dx is equal to uv v, multiply u and v, which is u is taken as x. You can write here all the steps. Listen here, u equal to x and u dash is equal to 1, u double dash is equal to 0. Now multiply these two, uv, x into minus e power minus x. Then u dash v1, 1 into e power u minus by formula minus u dash into v1, 1 into e power minus x, uv, u dash v1, then u double dash v2 plus u double dash v2, u double dash is 0 into v2 minus e power minus x. The derivative becomes 0. We can stop the process here. Now multiply or take e power minus x as common. E power minus x is removed as common. Here minus 1 into x minus x. Here e power minus x removed, so remaining is minus 1. Here product is 0 is in product, that totally becomes 0. So integral x e power minus x dx is equal to, add the constant of integration c at the end. So x e power minus x dx is equal to e power minus x into minus x minus 1 plus c, or we can write minus x e power minus x minus e power minus x plus c. Both are equal. So this is the idea to complete by Bernoulli method. Given problem as a product of two functions, you can go with the Bernoulli formula or integration by parts. Bernoulli is applicable only if u is an algebraic function and its power is a positive. So it is a positive power. So it is an algebraic function. We are moving to Bernoulli formula. Write Bernoulli formula here. After choosing u equal to x, the remaining all the terms are chosen as dv, and then integrate this dv, you will get v, and then differentiate u according to the terms we needed till the derivative becomes 0, and then integrate successively, that is repeatedly integrate the functions the terms which is needed to you. If the derivative becomes 0, we can stop that process here also. Second derivative is 0, so repeated integration of second time is enough to complete the problem. So substituting these terms in the formula, we can complete in this way. So x e power minus x dx is equal to minus x e power minus x minus e power minus x plus c. In the example we have one formula, that is one problem, that is x e power x dx, that will have the answer as x e power x minus e power x plus c. It is the answer for x e power x dx. So I can directly complete this as a homework, because only small variation in this is minus x, here we have plus x, that's all. So you can easily complete the problem. The answer of the x e power x dx will be equal to x e power x minus e power x plus c. Leave it as homework. That is an example 1 it seems. Next question, the given is x cube e power 2x. I think it is more interesting. Now we are in the second sum of exercise 2.5. Given x cube e power 3x, integral x cube e power 3x into dx. Can we apply Bernoulli here? There are two functions, they are in product. The priority is given to the particular order: hilate, inverse trigonometric, logarithmic, algebraic, trigonometric, then exponential. Here inverse trigonometric. I means inverse trigonometric. Take it as IT, inverse trigonometric. Here only trigonometric function appears. So there are both two functions, one is algebraic, another one is exponential. So priority is given to algebraic function, that is taken as u. Can we go with Bernoulli? Yes, we can go, because the power of the x is a positive term. So we can go with Bernoulli. So choose this is equal to, the given problem is taken as integral u dv. So we can choose according to the condition u as, by the order of priority, u as x cube, and the remaining are dv. dv equal to integral dv are remaining. integral e power 3x dx. The particular term is taken as u, the remaining are integral dv. Now, to get v, integrate dv and then find successive derivatives for u. U dash. Here we are differentiating, here we are integrating. U dash, exponent formula, derivative of x power n, d by dx of x power n equal to n into x to the power n minus 1. So x cube is 3x square. Look at carefully here. Should get familiar the formulas of consecutively differential integral. For these type of cases, we are applying consecutive differentials here and repeated integrals here. You need not get confused these type of problems. So do it very carefully. Here we are doing successive differentiation. Here repeated integration. So differential integral formulas will vary according to the functions. So you should keep in mind very clear. Now u double dash, I am differentiating here, okay. U dash is 3x square, then u double dash is 6x. 3 remains constant, the x square become 2x. Derivative of 3x square is 3 into 2x, that is equal to 6x. And then again differentiating u triple dash, 6 into x become 1, that is equal to 6. And then u 4 of x, 4 dash is equal to, this is a constant term. When differentiating it becomes 0. Any constant while differentiation become 0. So 4 times you have differentiated, the fourth term becomes 0. So okay, now we have to find, we should find v. Integral dv is v. Integral e power x. What is the formula of integral e power x dx? E power ax by a plus c we have. So substituting here, e power 3x divided by 3, or we can keep 1 by 3 e power 3x. Then v1, how long we should do repeated integration till v4. So v1 equal to, now integrating again, this is a constant taken out, the integral of e power ax, again e power ax by a, so one another term 1 by 3 e power 3x will appear, or e power 3x by 3 you can write, both are same, e power 3x by 3. Now multiply these two, which will be equal to e power 3x divided by 9. Then v2, again integrate the term. Now 1 by 9 as constant, we can keep it same. Then e power 3x remains again integrated, again it will be e power 3x by 3. Multiplying, we will get e power 3x by 27. And v3 equal to 1 by 27 is constant. So e power 3x, again integrating e power 3x, it will be e power 3x by 3, that is equal to e power 3x by 81. We can stop the process because u4 is 0, so product of u4 and v4 becomes 0 anyway. So stop till this step. So find v from dv and then do repeated integration for 3 times, because u4 becomes 0, so we may not find v4. Now we can enter all those things in the formula, Bernoulli formula. By applying Bernoulli formula, we can have integral u dv equal to by Bernoulli formula, integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. Here in our problem, integral x cube e power 3x dx is equal to uv, u dash v1, then u double dash v2, then u triple dash v3. So okay, substitute uv x cube into 1 by 3 e power 3x. So x cube e power 3x by 3. Multiplying these two, x cube e power 3x by 3. Then these two terms, 3x square e power 3x by 9. uv minus, by formula we have minus, apply minus here. Then u dash uv, then u dash v1. u dash and v1 are multiplied. 3x square into e power 3x by 9. 3x square into e power 3x by 9. uv minus u dash v1, then u double dash v2 plus u double dash and v2. u double dash 6x v2 e power 3x by 27. So 6x into e power 3x by 27. And then by formula we have minus, plus minus, plus again minus, by formula minus, u double dash v2 we have u double dash v2 we have completed, u triple dash with v3, and then here 6 into e power 3x by 81. e power 3x by 81. So okay, you can take e power 3x as common from all the terms, and the terms which are simplifiable we can simplify. Here it is equal to taking out e power 3x as common from all the terms. So this is x cube by 3 remains in the first term, and here we can cancel 3 with 9 as 3. So e power 3x is taken out. So remaining is minus x square by 3. And then here we can cancel these two by 2 times 3 here, 9 times 3. So remaining are e power 3x taken out. So plus 2x by 9 is remaining. And then here we can cancel by 3, that is 2 times, and here 27 times. So remaining are e power 3x is taken out. Remaining is 2 minus 2 by 27. So this plus constant of integration c, add the integral value at the end, plus c you can apply here also, constant of integration. So this is very easy. u is x cube and integral dv is e power 3x dx. Find successive differentials till the u becomes 0, and then according to it find the repeated integral values, and then apply in the Bernoulli formula. Integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. How many terms you require, you can extend the formula till that. So integral x cube e power dx is equal to uv minus u dash v1 plus u double dash into v2 minus u triple dash into v3 plus constant of u4 becomes 0, u4 0, therefore v4 also when multiplying becomes 0. So you can stop until this step, and then here remove e power 3x common and simplify the term which are simplifiable, and then the final answer is e power 3x into x cube by 3 minus x square by 3 plus 2x by 9 minus 2 by 27 plus c. Third question is simply log x is given. So we should find integral log x dx. We don't have direct formula to integrate. So this is also taken as u dv. Integral log x dx is equal to integral u dv. So simply take u as log x. No other terms appear here, no more functions. So remaining are integral dv. Integral dx is equal to integral dv. U equal to log x. U equal to log x. And integral dx is equal to integral dv. Integral dv equal to integral dx. U is log x. Integral dv equal to integral dx. Integral dv equal to integral dx. Here, what is the derivative of u dash? 1 by x. U double dash minus 1 by x square. U triple dash 2 by x cube minus 2 by x cube. Here the derivative, when we find successive differentials, u dash is equal to 1 by x, u double dash is equal to minus 1 by x square, u triple dash is equal to 2 by x cube. Look at the denominator, its power is increasing. Here we have 1, here we have 2, here we have 3. So it will not end at any time. So you cannot go with a Bernoulli formula. If the derivative of u ends at a point, you can choose a Bernoulli. Here it is impossible. So you can choose on another formula, that is integral u dv equal to uv minus integral v du. So integral u dv equal to uv minus integral v du. The function chosen as u reduces to 0 at the time of successive differentiation at any of the points. You can choose as choose Bernoulli formula. Otherwise, it is not possible to choose. Here, u dv equal to uv minus integral v du. So we need u, v. So u is already we have taken from the question itself, u equal to log x. Then dv. From dv we can find v. So dv equal to, which implies, or I can write here, which implies integral dv is v, integral dx is x. Integral dv become v because integral dx means x. So integral dv equal to v. Integral dt means it is t. Integral d theta equal to it is theta. Okay, like this we can apply here integral dv v, integral dx as x. It's okay. Now substituting in the formula, what is du? Find dv and v and du here, which implies du by dx, or du equal to 1 by x. Du by dx is equal to 1 by x. Du by dx is equal to 1 by x, which implies du equal to 1 by x dx. And then here integral dv equal to integral dx. So integral dv v, integral dx x, so v equal to x. So substitute in this formula. Integral log x dx is equal to, by formula uv, multiply u and v. U is log x, v is x, multiply of these two, x log x. You cannot multiply log x into x. So x into log x minus integral v into du. V is x. By formula v du, v is x. Then du means 1 by x dx. 1 by x dx. dv means 1 by x dx. The formula is uv integral u dv equal to uv minus integral v du. So u and v are log x into x, product x log x minus v du, integral v is x, du is 1 by x dx. Now cancelling these two, we have integral dx only. So which is equal to x log x minus integral 1 dx or dx. X log x minus x plus c. So this is integral log x dx. Just to keep in mind as a formula, whenever integral log x enters, you can directly go with this formula x log x minus x plus c. Already we have found two more formulas. One is, these are all special cases, x e power x dx. I told you this is in the example number 1. Answer for this x e power x. Write this x e power x, then minus e power x plus c. And then for x e power minus x dx, here we have minus, both are minus, and the power also minus. Minus x e power minus x minus e power minus x plus c. This is the formula for x e power minus x dx. And here we have integral log x dx, which is equal to, here substitute in the e power x log x log x minus x plus c. Keep in mind these values directly when we go on the problem is because we can apply directly these values if possible. Keep in your mind these formulas also. Yes, we can derive these such steps, then only we can enter into the formulas. But for 3 marks, you should do all these steps. If it is a 5 mark, when it appears any one of the steps, you can directly go with those results. Now here, log x is given, integral log x dx, log x u equal to log x taken, the remaining is integral dv, that is dx. U equal to log x, integral dx is integral dv. Then the derivative of u du by dx is equal to, here is a function of x, so differentiate with respect to x, du by dx is equal to 1 by x, and du equal to 1 by x dx. The integral dv equal to integral dx, which implies v equal to x. Here, substituting these values in integral u dv, uv minus integral v du, u is x, v equal to log, u equal to log x, v equal to x, multiplying x log x, minus v into du, x into 1 by x dx. Du is 1 by x dx. Now cancel these two x. Okay, x log x minus dx, integral dx become x, so x log x minus x, or you can take x as common, x into log x minus 1 plus c we can write. Question number 4, x log x. Given x log x, integral x log x dx. Find the integral of x log x dx. By the order of priority, I late log and exponential algebraic appears. So logarithm is given priority. So choose u equal to log x. U equal to log x. And then remaining are integral dv. This is in the form of integral u dv. U is given priority to x. So remaining integral dv equal to integral x dx. Here u equal to log x, we cannot go with Bernoulli. So choose the formula integral u dv equal to uv minus integral v du. So we have u and we need v and du. From u find du, from integral dv find v. Now u equal to log x, du by dx is equal to 1 by x, which implies du equal to 1 by x dx. And we have integral dv equal to x dx, integral x dx, which implies v equal to integral x means x power 1, that is x square by 2. Here differentiation takes place, here integration takes place. Don't confuse the formulas. Be strong with the formulas of differential integral while doing these type of problems. Then we, here we find by u we can find du, and then integral dv we can find v. We can go to the formula here, apply in the formula. Integral x log x dx is equal to uv, multiply u and v, x square by 2 into log x minus integral v into du. V means x square by 2 into du. Du means 1 by x dx. 1 by x dx. Product of v into du means x square by 2 into 1 by x dx. We can simplify here the x and x square. Take 1 by 2 as common out. So x by 2 into log x minus 1 by 2 into integral x dx. What is the integral value of x dx? X power 1. Integral of x dx means x power n formula, x power n plus 1 by n plus 1 plus c. So which is equal to x square by 2 log x minus 1 by 2 into x square by 2 plus c. can multiply or take out x square by 2 as common, or you can write it as answer x square by 2 log x minus x square by 4 plus c is the required answer.